Hello everyone. So pretty intimate session, and I think we're a bit late on schedule, so that's good because I'm maybe gonna skip some parts that were pretty technical. Yeah. So the idea of this workshop, it's called a hack house. So I assume people would have computers. Obviously, it's not the case. But yeah, so the goal was kind of to show how to quickly build a point system. So a point system are, people have mixed feeling about them, but we believe that it still brings some transparency, yeah, to users of how those points are, like, they can get an idea of what their actions actually do, and if those actions are entitled to get some rewards at some point. Even if the translation of points to actual rewards is later decided later on, at least you know what actions on the protocol are valued by the team. So this is why we chose we'll use a point system for our project Suzaku. Suzaku is a risk-taking protocol specifically tailored for Avalanche layer 1s, and so helping L1 bidders to bootstrap the cryptoeconomic security of their networks by having more collateral staked by the validators, basically. And so I'm gonna, I think, quickly run you through the process of how, in our case, we compute points based on the collateral that the user puts into the system. And it's pretty straightforward. It's because we decided to build this with Dune, and also in transparent fashion, so that users can also come in and see the exact way that we compute points. So helping, improve transparency in the whole system. We've seen that there has been some drama around some other point system where two people did the same thing and had different results, different amount of points. Here we want to be pretty transparent about it. And so basically, when people come into the protocol, so I hope you know a bit of SQL, because Dune uses SQL for queries. So when some people come into the protocol, they will deposit collateral in what we call the collateral contracts, and this will emit some events, basically. So when I deposit and when I withdraw collateral, we have some events. So let's look at this first query, which sounds, yeah. Yep. Yeah, so pretty technical, right? You're all hackers. Yeah, so basically the first step that we need to do is to detect the events where someone comes in and either deposit or withdraw collateral to the protocol. And from there, what we can do is get the address of the depositor and at what time did they do that, basically. So this is the first thing we need. To do that, we deploy on Sepolia because Dune doesn't support Fuji testnet because they are very expensive. So basically you can go into here on the left side. You have the Sepolia blockchain. And for each blockchain, you have a bunch of tables. Here we are interested in the events table, as our smart contracts basically will emit events at deposit and withdrawal. So let's see, logs. It's in the log table, right? So we use this Sepolia log table. Then we filter by our smart contracts that we've deployed on Sepolia to get the events. And then we here need to filter by what topics we want. So the deposit event in this case. To translate the event to this hexadecimal string, right? The topic. You can use the cast CLI from Forge Foundry. So basically, what you do is you take the definition of the event, you paste it into the Forge CLI. It will give out this hexadecimal string that you need for filtering. So here, what I filter is I want the topic to be either deposit or withdrawal of collateral. And then from there, I can, so get those events and tags them as either deposit or withdrawal. And also, might happen that the staker and the recipient are different, so I get those two addresses. Also, one little trick here is that I will use a positive result if it's a deposit, and a negative result if it's a withdrawal. This way I can, in other queries, be able to compute the balance at each of these hours, basically. We're not that many, so if I'm not clear, don't hesitate to interrupt, I guess. All right, so this is the first query, right? So now we have our deposit and withdrawal events. The second step is actually to get all the discrete hours that exist, because we will reward the users based on how long the collateral was in this pool. So we need basically to have the discrete list of hours. So to do that, I just took all the hours that I can detect in the simple block table, which is another table, and then it will just give me all the list of hours, basically. Pretty simple. So from this list of hours, what I can do first is, I'm not even sure. Well, I also need the price of the collateral. So for this point system, what we wanted to do is rewards the user based on the amount in dollars of collateral that they deposited. So we also need to gather the price of the collateral itself. So here, AVAX. So I just rounded, average the price of AVAX every hour. So here gives me, a table with the price of AVAX, all the hours. And then, once that I have that, I can actually do the biggest query, which is I want to compute the balance of every user's every hour. So to do that, I will query the hour table. Basically, I will query the hours table that I just computed with the list of all discrete hours and the collateral events. So deposit and withdrawal events. Basically, for each line, I say, what were all the actions of this user before this hour? So all the deposit and withdrawal they did before this hour. So let's say it's 6 p.m. Today. I take all the events that happened before 6 p.m. today, deposits and withdrawals. And from there, I can aggregate and compute what is the actual balance of the user at this stage. So I deposit 1, then 2, then I withdraw 1. So at the end, I have 2, right? And so this is how I compute the balance for each user's every hour. Then I just translate it to ETH. So in this case, we have this user who has a different balance depending of the hour, because they deposited then withdraw the collateral. And at the end, from there I can do the final piece, which is I compute the points, right? So I have the balances, and then I just join this with the AVAX price, right? The collateral price. Gives me a number of points. That is. And then this query I can launch it every now and then. So there is what is pretty cool is that with Dune you can actually call the refresh of the query from an API. So this will allow us to automate this, as well as you can query through the API as well the result. So from the web page we'll be able to just query an API and get this total number of points based on the address of the user. So yeah, pretty straightforward as well. So all these queries are public. So if you want to check them out later, you can go to Dune, and I think it's just Dune/Suzaku. And so you will see all those queries there. 5 of them, yeah. Events of the collateral, block hours, just all the hours in every day, and balance of the users per hour, the price of the collateral per hour, and then the points. So the final computing of points. Yeah, and so of course, well, you can do a lot of different things based on how you want to reward your users here. But yeah, that's the generic idea. Goal was to show that it's pretty straightforward. What is good is, Dune is free. So if you want to check it out, you can run the queries for free. You can, tweak around and make them fit your protocol. Of course, in our case, we'll have different collaterals, different pools that we want to reward with different maybe points allocation. All this we can do with SQL. And what is nice is that now people can also come and build dashboards on top of it, on speculate on how much they will get, airdrop, etc. Yeah. So yeah. Do you have any questions about that? Yeah. Yeah, I think, well, it depends. So for our points, for the Suzaku points, they would be using these queries. I think we would work with them anyway to make sure that all the points are accounted. So probably develop queries in conjunction with those teams. But if they need to have like their own points, yeah, they will need their own queries based on how they want to distribute points. Yeah. Because the smart contracts at first are not the same, so the place where people will deposit collateral or capital will not be the same in the first place. Yeah. Yeah, so we will deploy the contracts on the Avalanche C chain, the first step. So we'll be able to use Dune. Then, the second contracts, yes. Yeah. So the points will be, basically the points will be computed at the staking contracts level, so for collateral. But then, yeah, at some point we'll have our own network. Dune has a way for like networks to push data to it. So if we ever needed to migrate the staking contracts to this network, we would probably make sure that Dune has our network indexed as well. Yeah. So maybe what I can do is just do a quick overview of how Suzaku will work, because now that we're here, I have a few minutes left. Yeah, it was supposed to be a bit more hands-on, but yeah, not the right place for that. So Suzaku, the documentation is online if you want to check it out. It's docs.suzaku.network. So basically, what do we want to provide? It's first of all the best development stack. You've heard a lot about it today. So Avalanche, we believe, is the best development stack for layer 1 developers, and it will be even more prevalent in the near future. Then we want to provide those builders with crypto economic security to bootstrap. So how, as a nascent network, new network, I can boost my crypto economic security? We do that through restaking. And through Suzaku, what you can also do, of course, is get connected to trusted like operators, high-tier operators, who can make sure that your network will run properly and be able to scale and decentralize over time. And at the end of the day, yeah, the goal is to build an ecosystem of decentralized services around Suzaku, around the Avalanche ecosystem. Suzaku will build the Suzaku Relay Network, which is bringing censorship resistance on top of the Avalanche warp messaging protocol. And so one of the first services that will be part of this ecosystem. So now maybe let's just look at who are the participant of a risk-taking marketplace, because Suzaku is a risk-taking marketplace. So the first participant in a risk-taking marketplace is the staker, right? So I have AVAX BTC ETH. I want to contribute to securing networks of the Avalanche ecosystem because I believe in what they're building, and also because I want extra yield on my collateral. So I can deposit the collateral in the protocol through risk-taking for those big assets, or through staking if it's for the native tokens, native network tokens. So each of the Avalanche layer ones will probably have its own native token for gas and staking. So they can also go through Suzaku to basically get yield on those assets without having to run the operators. Because the second group of users of the protocol are operators. So those operators run the infrastructure on behalf of the stakers. Usually it's professional operators. But of course, in Avalanche, we have a bunch of OG validators, runners. I think, there is one in this room. And so they are trustworthy operators as well. So this is also why we will enable them to be part of one operator, which is like the Avalanche primary network operators. And as a network, I can choose to onboard those operators as well, saying, okay, I trust them. They are the Avalanche primary network operators, so I allow my users to basically stake with them and to validate my network. And of course, the most important part of this is also the networks. So I want builders that have either one, like everything is enshrined in one layer one blockchain. Most of the case is mostly the case in the Avalanche ecosystem, where people are using, for example, HyperSDK to encode all the specifics about their use case on chain. But we also provide a way for networks that are running off-chain components, software components. This is what we'll be doing with the Suzaku Relay Network. Basically, we'll have the consensus layer, which is running as an Avalanche chain, and around that, the relayers who are passing messages around. And the consensus layer makes sure that everyone is playing the game without delaying message passing in the middle. So those networks, of course, are the most important piece, and they can whitelist operators to validate the network. And the last part, to bring everyone together, is the curators. So the job of the curator is to, first of all, select sovereign networks to secure. So those networks we just talked about. They will do so based on the risk. So if they deem that the network is worth validating and that it's not too risky because of they know the team and they have audited the code and they know that also it's worth validating this in terms of rewards, right? They will select those networks. Then they will pick operators that are trustworthy, and basically based on the fact that they assume that those operators will do their job well and have the maximum return on the capital that they will delegate to them. And then they will distribute the rewards from the protocol to the stakers. So if we look at the overall flow, it's, as a staker, I come in with my collateral, with my capital, I deposit it in the into the protocol, and then I can delegate it to a curator. Basically, the curator job is evaluating all the networks that are available and all the operators that are around, selecting the best networks and the best operators. Then the operators, of course, they validate the network, and based on that, receive rewards. And the curator as well is rewarded based on the collateral that they brought to the system, and can choose how to redistribute those rewards to the stakers. So it can be like streamlining the rewards. For example, I'm rewarded in a native layer 1 token, for example, COC. If you're on the COCnet, you receive COC as rewards, and you just streamline the COC to stakers directly. Otherwise, you can also compound, like sell basically the token and compound the yield into the AVAX, for example. So you basically, when you withdraw, you receive more AVAX than what you had at the beginning because it has been compounded in it. Yeah, so that's a quick overview of how Suzaku will work. If you want to learn more, you can go check out the docs. There is more details of the different parts of it. Happy to answer questions if you have some. I guess it mostly comes down to what the points translate when it comes to rewarding the users. I guess the point system is a very good way to, at least making clear to users what activities are incentivized. So, like pointing them to partners, liquidity pools, or validating this network will give you more rewards than the other one for X or Y reason. I guess the pitfalls are mostly on the side of how those points will be translated to actual tokens. Well, to be honest, we didn't go through this phase yet. But I think what is also nice is that you can change. It's kind of it's a modular, right? You can distribute points at some point for this particular place, and then move the points somewhere else, right? Yeah, I think it makes sense to have points until you have your token outlet. Yeah, I think the main problem is not the point system itself, it's mostly how it has been used. I guess there is a way to find the balance to make it sustainable. But for me, it's useful in the beginning, before you launch your token. And this is probably what we'll see happening as well for, or at least we think so, layer ones that might launch without a token. So they will have points programs, yeah. But yeah, in the long run, yeah, I don't think it's super worth to have it for a very long period of time. But I think the system overall is here is a pretty good way, as I was saying. First of all, it's kind of transparency to users, and also as a protocol, basically, directing your users to the place you want them to be, right? So you have more control over what they are doing in your protocol, where they're deploying the capital or what action actually they are doing, right? So instead of everyone doing something because they assume that they will get rewarded at some point, right? Okay. So thank you for listening.